I'll do that now. Okay, I am now recording. Okay, and I will start this recording by saying that nothing I say or do can be used against me in a court of law. Okay.
You have the Fifth Amendment.
I tend sometimes to speak without thinking, so I ask all of you to not use any of this against me. I'm doing you a favor by recording this and posting it. So any, especially in this 2020 where there's a lot of, it's very easy to say something. I'm in the older generation, so sometimes we might say or think things that are lately coming out as being offensive to certain groups or participants. You know, and so I do apologize in advance if I ever try to make a joke and it comes across the wrong way. My apologies. Please try to correct me and get me into the proper frame for this world that we live in. Anyways, both of those questions so far, both of those situations that we covered were matters of probability because we're not looking at data. Probability is really more of a theoretical approach to likelihoods. We didn't do an experiment. We didn't actually flip a coin, correct? We just kind of assumed that it was a nice, perfect coin and asked, okay, what's the likelihood that something occurs? Probability in that sense is very theoretical. It's before you do anything, although not always, as we're going to see. There's theoretical probability and there's empirical probability. Those are two different sides of the same coin. And the empirical one, you do have some things that you're going to do in advance. But statistics deals with collecting data, organizing data, visualizing data, analyzing data. Do you see the common theme to these things? It's all about data. So let me give you an example of a statistics problem, even though we're not doing statistics yet. It's going to come a few weeks from now. In the Super Bowl, what's the very first thing that they do in the Super Bowl every year before the game even starts? Before, they come onto the field and there's always everyone celebrating, hey, it's going to be a great day. What's the very first official ceremony, huh?
The coin toss.
The coin toss, right? The coin toss is what the game starts, correct? So the NFL goes to some company and says, do me a favor, please. We need a coin to toss at the Super Bowl. And they say, no problem. We will construct for you a fair coin. And they make a coin and it's heads on one side and tails on the other. It's not a quarter. They don't flip a quarter, right? It's like a big disc that they flip. It's heads on one side, tails on the other. And they come to the NFL and say, here you go. And the NFL says, thank you. Is this coin fair? And they say, well, of course it's fair because, we're very good at what we do. So we made it that it's fair. But the NFL says, you know what? We better test that it's fair. So how do you test that a coin like that is fair?
You flip it a bunch of times.
You flip it a bunch of times. That's what I heard. You were talking, he was talking, I heard him over you, I'm sorry. You flip it a bunch of times. Now, how much of the bunch? 10?
I guess, yeah.
Okay, so if you flip it,
100.
100.
100, yeah.
Okay. Well, let me ask you a question. Let's go through a few theoretical exercises here. If I flip it 5 times, and it's heads every time, would I conclude this coin cannot be fair? Is that a valid conclusion if it's heads every time with 5 flips?
Yes.
Well, I can't conclude it's definitely not fair because 5 heads? Listen, I'm not going to say it's probable, but it's certainly possible. You ever roll 5 dice and get 5 sixes? It happens, right?
I mean, is there even a number that you can say that you can flip it as many times?
Well, yeah, we're going to calculate that. Yes, there's a specific number. We're going to calculate that. But there's no question, I would think, at least theoretically, that the more flips that you make, right? If I flip it 1,000 times and it's heads every time, would I answer it by saying, oh yeah, it's possible? I mean, yes, in theory it's possible, but imagine flipping 1,000 coins and getting 1,000 heads. How often is that going to happen?
Not likely.
Not if they're fair, correct? Is it possible? Yes, it's certainly possible, but it's not probable, correct? Okay, so 5 coins, that's okay. You know, 5 heads, all right. Things are not looking good, but I'm not going to conclude it's bad. 1,000, oh my, that can't be. So how about 100? Which would you do for 100? 100 heads, would you say this is not fair? How many is enough to convince you that the coin can't be fair? 1,000, we all said, yeah, that's not fair. 5, even some of you were already saying 5 was not fair, but I think 5, you know, okay, it's possible. What's the cutoff? Where do you go? 10? Who said 10? Someone said 10. Someone. Anyone? 10.
Yeah.
So
after 10, I'd stop.
After 10, you would just straight up stop.
Yeah.
What if the 11th was a tail? Would you still stop? Huh?
You wouldn't know if you stopped at 10, right?
Well, listen, you never know. And here's the thing about statistics. You never know. This entire year, if there's a statistics question, and I say, what can you conclude? You better never say, we now know this. You never know anything. You conclude. Okay, you say the data suggests. And there, who was the one who asked me, like, what kind of term? Well, I just saw you. Where are you? Tatiana. The data suggests that this is the most likely outcome. If I flip a coin 1,000 times and I get 1,000 heads, the data suggests the coin is not fair. I can't say the coin's not fair. I don't know. I could be the unluckiest person on the planet. But the data suggests that. So we're going to have a lot of terminology and statistics that you might not be used to, right? You're going to have things called hypothesis testing, where we're going to reject or not reject a certain hypothesis over another. Things that you're not, terminology that you're not familiar with. But the basic difference between probability and statistics is all about data, collections of data. Whereas probability is more of likelihoods for outcomes. Now, why are they intertwined? Because if I said, what's the likelihood of getting 5 heads if you flip 5 coins? Versus what's the likelihood of getting 1,000 heads if you flip 1,000 coins? We'll compare those likelihoods, and that will explain why you might feel that 1,000 is out and 5 is not yet enough. Okay, so they're connected. And it's that connection that is really, really important. Okay, so this is the prelude to the class. What I'm going to do now is I'm going to share my screen after all. And I have the notes up here, if I can find them. Okay, so let's see. How do I share my screen? 1 second. There's probably a share screen, isn't there? Share screen in green. Okay. No, that's just one participant at a time. How do I share my screen? Anyone know?
It should be right next to the record button.
Got it. Thank you. I'm a little noobish.
Yeah, now you're sharing.
Now I'm sharing. Okay. All right. So lesson 1 today and on Wednesday is all going to be about lesson 1. Try to cover up those answers that are in blue. I don't have non-answered answers already.
Will these
Yeah, you're gonna upload
slides
those.
be up on Canvas at any point?
Yeah, it seems based upon what I read that I will be sharing these on Canvas. So yes. Okay. And they're also, if we're recording the video, they're also going to be there. So you'll have twice the opportunity. So we're going to start this course with the difference between empirical and theoretical probability. Okay. These are not my notes. These are the notes from the department. They say, when you teach this course, use these notes. So I'm really supposed to follow these and not go off on my own too much, which I've already done for the last 15 minutes. But I've always been a rebel, so you're going to get a lot more of that. But nevertheless, here we have lesson number 1, the difference between empirical and theoretical probability. Theoretical probability is like our first example with the flipping a coin. We assume it's fair. We don't actually flip a coin. We just assume it's fair coin and say, what's the likelihood of a certain event? What's the probability of a certain event? Well, how many ways can I get it? How many outcomes are there? One over the other, and there's the answer. That's what we did before. That's theoretical probability. Empirical probability is something like, what's the likelihood that it's going to rain in Los Angeles tomorrow? That's not something you can really answer by theory. The likelihood that it rains, what, you're gonna, I mean, I don't even know how you would do that theoretically. But what you could do is you can go back throughout various weather records for the last few years in Los Angeles and look at every day that was like today in terms of whether it was overcast and temperature, etc., things that were very similar, and see how often it rains the next day. So let's say it happened 1,000 times and 800 of those times it rained. I might say that there's an 800 over 1,000 likelihood that it rains tomorrow. I'm using past data to calculate a likelihood for the future. Does that make sense? That's what empirical probability is, using past data to calculate likelihoods for future events. So let's look at the first example. If today's forecast says that there's an 80% chance of rain tomorrow in Northridge, where are they getting that from? Well, it said that in the past, when the weather was like it was today, it rained the next day 80% of the time. We are using past data to determine the likelihood of rain tomorrow. They don't look at the sky or look at the weather forecast with the green screen and whatnot like you see in the news and say, well, that hurricane-looking thing that's swirling around and coming here, it might miss us, it might not miss us. That's not what they do. They look at historical data. Example, you roll a die 100 times and you get a 3 21 times. So if I said, what is the empirical probability of rolling a 3, then what I'm asking for is, how likely is it based upon past data that I would roll a 3? And I would say, well, I have 100 rolls. 21 of them gave me what I want. So apparently 21 of the 100 times I got what I wanted. And therefore the empirical probability would be 21 over 100 as a decimal 0.21, or as a percent, 21%. Any one of those is mathematically fine. If I said, what's the theoretical probability of rolling a 3? I am not asking for any data to be used. This is theoretical probability. This is like what I started with, the very first thing we talked about. How many ways can you get a 3? 1. How many outcomes are there? 6. Are those outcomes equally likely? Well, if it's a fair coin, yes. And therefore, it should be 1/6. Now, whoever wrote 1/6 or 0.67, I promise you that was not me. Because 1/6 is nowhere near 0.67. Does anyone know what 1/6 is? Anyone want to try that?
I'll give it a try, but it'll take a while.
Why would it take a while? Wait. Why would it take a while?
Do you want us to do it calculator, or do you want us to do it by hand?
Well, let's do it both ways. Let's first do it by calculator. What is 1/6 by a calculator?
0.16 repeating?
1/6 by a calculator is not 0.6 repeating.
0.16.
It's
0.16 repeating. Yes, 0.16 bar. I'm sorry.
Yeah.
Yes, 1/6 by a calculator is 0.16 bar. So that's very different than 0.67. Whoever wrote that. So this is good. This tells you that you can't trust any of the stuff in blue that you're going to see in these notes, because they're not mine. And that was a mistake on the very first page. But it's very important to know how to do fractions. So hopefully you can see all this. Can you guys see this? Is this large enough? Can you kind of see this?
Yeah.
A little bit.
One second.
Not really.
Hold on.
No,
No,
I
not
can't
at all.
see it.
Oh, you just gotta click on the zoom.
Wait.
Stop share
If I
screen.
unshare, it should be loud. It should be larger, right? How do I?
Oh no, you're fine. I mean, like, there's a
Hold on.
button there.
Let's
that
stop
you
sharing
can
for a
press.
second. Hold on. How's it sound? Can you see this?
Yeah, I can see it.
And everything's fine?
I can't really see that. But is there like a zoom button that you can kind of zoom in?
You can pin the video.
Yeah, just put on speaker view.
Okay, how's that?
That's perfect.
Okay.
Yeah.
So we got, see if I can, okay, so we got 1/6, right? And the question is, right, what is 1/6 equal to as a fraction? This is a very important skill you should have, whether you're going to teach math or not. You should know how to convert a fraction into a decimal. Because conceptually, what is a fraction? A fraction is a division problem. When we look at 1/6, we're saying what is 1 divided by 6? How do I do a division problem? I do bottom into top. So I do 6 into 1.
Mhm.
What is 6 into 1? Well, it does not fit, does it? 1 is too small.
That's
What do I
zero.
do, right? I add a 0. And then I ask, okay, how about 10? Does 6 fit into 10? How many times?
Yes, once.
Once. So then you multiply 1 times 6 and you subtract. What's 10 minus 6?
4.
4. Add a 0. 6 into 40, how many times does it fit evenly?
6.
6
Six times.
times. Do it again. 6 times 6 is 36. It's getting down there. I'm sorry. But you notice that if you subtract again, you get a 4 again.
Yeah, so you keep repeating.
I'm going to keep getting 6's, 6's, 6's forever. So how do I write 6's, 6's, 6's forever? I write it as 0.16, and the bar is only on the 6. The bar is not on the 1 because the 1 does not repeat. Only the 6 repeats. So 0.16 bar or 0.16 repeating. Does that make sense? That's a good skill to have, whether you're a math teacher or not. Okay, so I'm gonna, I have a chat question here. I hear it. Oh no, that's before. Use the whiteboard on Zoom. Use the whiteboard on, there's a whiteboard on Zoom? Oh yeah, but then I gotta do it. I have to, it's tough to write. I know what you're saying. It's very tough to write if you ever tried it. But maybe it's better than the alternative. We'll see. But anyways, I'm gonna share screen again. Hold on. And I'm gonna close that. Okay. All right, so we're back. Any questions so far? Okay. So the graph below shows the results of 25 flips of a bent nickel. Now, a bent nickel is most probably not fair. I don't know offhand whether or not it's more likely to land on the round side or more likely to land on the, the concave side. But let's take a look at this graph and let's understand exactly what the graph is asking for. It's, if you look at the bottom is labeled as number of flips, correct? The number of flips starts at 0 and goes to 25. Does it make sense that it goes to 25? Well, we're flipping 25 times, right? So why go any further? On the vertical axis, it's asking for the proportion of heads. How many heads are there? Not how many, I'm sorry, but what percent of the flips are heads? So the first coin, the first flip, the first dot, at that point, after the first flip, I say, I believe, based upon the data so far, that heads has occurred 100% of the time. Because 1.0 was the same thing as 100%. So, question, was the first flip a head or a tail? Well, if it's been heads 100% of the time, the first flip was a heads, right? Now look at the graph. The second flip, the second dot, it's still been heads 100% of the time.
So each dot is a head?
Well, no.
A flip?
Well, each dot is a flip.
Sorry.
Right? Each dot is a flip. If you go from the left edge of the graph to the right edge of the graph, we have 25 dots. Each dot represents a flip. After the first flip, we say we've had heads 100% of the time. Well, that means the first flip was a heads, right? After the second flip, we're still at 100%, which means the second flip was what?
Ahead.
A head. But after the third flip, now we say it's been head 60-something% of the time. Hard to see exactly what, but 60-something%. So was it a heads or a tail on the third flip, huh?
Tail.
It was a tail on the third one.
It had to have been a tail, correct?
Right.
In fact, you can see a little pattern here. Every time it drops, it's a tail. Every time it goes up, it's a heads, right? Because every time I get a heads, the proportion of heads increases. And every time I get a tail, the proportion of heads decreases, correct?
Mhm.
We can quickly just run through it and say, I'll do the first 5, and then I'm going to want someone to do the next 5. So I'll do the first 5. Heads, heads, tails, heads, heads. Do we all agree?
Yes.
Okay, so I just finished the first 5. Someone say your name so I know who's talking. Someone want to volunteer?
Tails.
Well, who's talking?
That was me. I'm sorry, but I
Okay.
wasn't on mute.
What's your name again?
Tomas.
Okay, go do the next 5.
So the next 5 would have been the sixth flip would have been a tail, and then the next flip would have been a head, a tail, and a head.
Wonderful. Someone else, next 5.
I'll do it.
Go for it. Who's talking?
Brianna.
Brianna, go for it.
So it went, the next one, the 7th one was heads.
So
And
so just so you know, we're at flip number 10 right now.
okay, sorry, I got off a little bit.
No
Okay, so
problem.
10 is heads.
Right, so
11
10 is heads. Sorry?
11 is also heads.
Good.
12 is heads. 13 is heads. 14 is heads. And 15 is tails.
Wonderful. Who would like to do the next 5?
I'll do it.
What's your name, please?
Megan.
Megan, go for it. Next 5.
So 16 is tails, 17 is tails, 18 is heads, 19 is heads, and 20 is tails.
Wonderful. And to round up the last 5?
Do it.
I'll go. Oh, never mind.
Who's going?
Go ahead.
I
Gary,
guess
is that
I
you?
can.
No, she can go. That's cool.
Who's that? Who's talking?
Me, Talar.
Okay,
I
go
can
ahead.
try. So 21 is heads. 22 is tails. 23 is tails. 24 is heads, and 25 is heads.
Wonderful. Does that make sense? Are there any questions so far? So if I asked, based upon the 25 flips, what is the empirical probability of getting a heads?
Would it be like
well-
65% of the time?
Well, there's 2 ways of doing it. There's 2 ways of doing it. One way is to go back through and count how many of the 25 were actually heads. And then say whatever that number is, do that over 25. But there's an easier way. Just read it off the graph, because the graph has been updating for us the proportion of heads every step of the way. Right? Every step of the way, it's been updating manually. So at the very end of 25, what are we at? 60 what? 64%? Somewhere
About
around
that.
there? Yeah, it's kind of hard to tell exactly. If my life depended upon it and someone said, if you're wrong, even by 1%, I will kill you. These things do happen. Then I would probably go back to the beginning and count exactly how many heads there were, and then double check and then triple check just to make sure. Okay, but as long as I'm okay
I'd be
with
dead.
rough, huh?
I'd be dead.
You'd be dead. Okay, well, I'm sure somebody out there would miss you. I don't know you yet, so I don't, but I'm sure somebody would. Just, no offense. All right, but does that make sense so far? So these types of graphs, you might see one of these on a quiz or a test. Are there any questions on it? So far, so good. I only see 6 of you because you can see my screen, so you know who I'm looking at. But hopefully the rest of you don't have any questions. Do I have any chat? No chat. Okay. So one of the biggest rules in all of statistics is called the law of large numbers. The law of large numbers says In random, we can just read it. In random situations, what does that mean, random situations? That means we don't know what the outcome is going to be in advance. In this case, if I flip it, is it a heads or a tails? I don't know. It'll be one or the other. I know what the outcomes might be, but I don't know which one it will be. That's what we call a random situation. I know what it might be, but I don't know what it will be. So in random situations, as the number of trials increases, the proportion of successes approaches a specific value, which we will call the probability. So if I look at this table here, this is not the same situation. How do I know it's not the same situation? Because the second flip was a tails. And in the last example, both the first and second flip were heads, right? Remember that? In this situation, it goes heads and it drops to tails immediately. But a coin was flipped 30 times. So look at the graph in the beginning. What do you notice about the graph on the left side, the first 15 flips or so, versus what happens to the graph as we get closer and closer to 30 flips? What's the major difference between the left side of the graph and the right side of the graph?
A lot more dramatic.
Well, dramatic is a good term. There's a lot more fluctuation on the left, right? It goes up, way down, way up, down a little, you know, versus the right side where it really, really kind of sticks close to this value of 50%. Does that make sense? And this is why we flip coins many, many, many times. Because the more times you flip it by the law of large numbers, the more likely you are to have your proportion be close to what you expect or to the true value. Now keep in mind, you will never know the true value. In statistics, you can never know anything. Well, not necessarily. If I'm curious what the outcome of the coming election is going to be, I could always, if I wanted, to ask every single voter in America what they're going to vote and hope that they all tell me the truth. In that case, I might know. But since it's not feasible to do that, both for time and money, and people might lie, change their minds, etc., you can't really know. But if I said, for example, what is the likelihood that a randomly chosen person in our class is a male versus a female? I know that because I know who's in my class. I see you. I can just count. So there are sometimes you know things, but in general, we don't know anything. It's a good rule of thumb to live by. We don't know anything. So based upon this graph, what is the probability? Remember, how do we define probability? The long-term law of large numbers approach. What is the probability of heads for a coin flip based upon this graph? Well, it seems to stabilize around what value?
Around 50%.
Around 50%, right? Correct? So that is the probability of a heads based upon this data. The stabilized value is 50%. What's the empirical value? Exactly the same thing, 50%. Right? They're the same. They have to be the same because one is defined in terms of the other. Now, do the results illustrate the law of large numbers? Explain. So let's see their wording. Yes. With an increasing number of flips, the proportion of heads is approaching 1/2. If you had just written yes as your answer and thrown in a period because it's the end of a sentence, how many points do you think I would give you?
0.
0.
0.
We know that, by the way. We know that one. 0. Because not only does it say the word explain, even if I didn't say the word explain, if I just didn't leave it off, I forgot to say explain. This is a college class. There are no yes or no answers. Anything that is asked, there is an implicit explain as part of it. Are there any questions so far? We're going to stop here today. I only did basically 2 or 3 concepts. On Wednesday, we'll do some more. We're going to finish the first chapter on Wednesday. That's the goal. Basically, essentially a chapter a week, maybe a little bit faster. I think we have slightly more than 15 or 16 chapters. but this is the general format of the class. So are there any questions? Yes, Zoe?
I have a question. Will you be able to make your notes available to us before class so we have a chance to go over it?
That's
Or
a
no?
great idea. I'm gonna try to figure out with my completely noobish understanding of technology how to post this recording and how to post the notes on Canvas prior to tomorrow evening. I can't promise I'll do it tonight, mainly because I'm really tired after a long day of work, but I will do my best to have it done tomorrow.
Okay, just to kind of supplement like reading the textbook.
100%. I totally understand. You don't have to explain why. I get it. Even though in general you should explain why to get full credit, but I do understand now exactly what you're asking and why you're asking. I will do my best to have that done. And if I forget, if it just slips my mind, you're more than welcome to send me an email on the hour, every hour. I won't hate you, reminding me, hey, it's 3 a.m. You said you do it, so get it done. And then at 4 a.m. the same, and 5 and so on until I get it done. Is that okay?
I have a question.
Yes.
Will you be providing links for the Zoom meetings every single time we have class?
So
or
hopefully,
around what time can we expect that?
so hopefully, if I did it correctly, the link that I sent out, which you're now on, is repeating every Monday for every class for the whole semester.
Okay.
And if I can
So,
figure out how to get Wednesday on the same thing, then that'll be amazing.
Okay, so what you're saying is that Monday's link is only for Monday, the one that you just sent us,
The
like,
way it is now, yes.
okay, and then you'll send a separate one for just Wednesday. So we'll have
Correct.
2 separate links to click on every day.
That's right. But if I can figure out how to have it done on the same link, which will be even better, I will let you know, and we'll do that instead.
Okay,
And
thank you.
the office hours, by the way, will be the same link
Okay,
because it's right before this class, so it just leads right into class. Why not?
okay, thank you.
At least the Monday, Wednesday office hours. I can't promise about the Tuesday, Thursday office hours, but the Monday, Wednesday for sure.
All right, thank you.
So,
Okay.
kind of going back to your your syllabus, the only things that are getting graded is the final exam and the quizzes
That's
for your
correct.
class?
That's
Okay.
correct.
So there won't be
Homework-
any other
Are you-
homework for us to do, but it won't be.
You'll get a little bit of extra credit for attendance.
Okay.
Perfect or near perfect attendance will get extra credit. But in terms of the homework, will not be great. It will not be graded. First of all, it'll be gone over, or at least if there's questions, I'll go over it in class. I'm not going to go through it, word by word. But you will not get credit for homework.
And so your homework assignment posted on Canvas, or would you go over that in class?
We'll figure it out as we go along. I kind of,
Okay.
I'm off the cuff type of guy. I kind of
Yeah,
just,
no,
I
I get
kind
it.
of wing it. Like this haircut of mine that I decided to get last month. So, I'm just winging it here. All right. Any other questions?
I have a question.
Yes.
What is the calculator you were recommended?
The TI 84 Plus. I have 2 calculators that I use regularly. I have an HP calculator and I have a TI 84 calculator. And while I love my HP calculator, it is not one that most colleges use. They use a TI. And I readily acknowledge this is better for statistics than this.
And that TI, when you're showing us things on how to use it and how to go about
Yeah,
it.
I will go button by button. Press this.
Because it looks really small, and I don't think I'll be able to
Well,
see all that, to be honest. Maybe if you put it right up to the screen.
you know what?
But I don't know if there's an online version.
I'm going to go to CSUN tomorrow. I might even buy a document camera.
Okay.
And if I can do that for relatively cheap, maybe that's the best way to go. We'll figure it out.
Yeah, I don't know if I'm the only one, but I had that idea. So.
Remember, general rule, if you have a question, 10 others have the same one or an issue. I'm trying to.
I can afford that.
What?
I don't know if I can afford a calculator like that.
Again, it's my recommendation, but I'm going to look for online alternatives that you don't have to pay for. Okay. We're doing our best here. And hopefully when you're a teacher, you won't be as unprepared as I am. but more importantly, you'll be as willing to work with your students as I always am. Okay, yes, another question?
Yeah, I have.
Oh, shut down. Yeah, Brianna, go ahead.
Just real fast. I have a scientific calculator. Does it have to be a graphing, or can we just use the scientific?
I don't know if scientific calculators will have all the options that I plan to use.
Okay.
And I feel that you're going to need to use.
There's
Check
used
eBay
one
for calculator.
on
You can always check eBay. I'm sorry?
There's used ones on eBay of the one you're recommending for $35.
Oh, 35. That's like $35 more than free. So that's great.
Compared to
plus
the
shipping and handling, of course.
new.
Huh?
Compared to the 120 new, yeah.
Yeah, and you can rent them also, by the way. CSUN will rent out calculators. I don't know the cost for renting, but you can look into that as well. And I think those are pretty cheap as well.
Can you actually type in the name and model of the calculator into the chat?
I could. Let's see. TI-84 Plus. Mine is actually a TI-84 Plus CE. I don't know if that's different versus a straight up TI-84 Plus.
The CE stands for color editions, so it just color codes your graphs.
Oh, okay. Well, you get color graphing. How do you pass that up? But you're not going to need that for this class.
Do you think the TI-83 Plus is the same? I know it's a graphing calculator.
Well, I don't want to promise that it's the same. My assumption is that it will probably be, but I can't. I'm not promising.
Okay.
I'm not promising. Okay. So if there's no other questions, then I will see you all on Wednesday. Have a great night and go away.
Thank you. Thank you.
And if there's other people who have last minute questions or personal questions, I will stick around and answer them.
I just have a small comment. My boyfriend walked in right as you said, "Have a good night, go away." And he started laughing, so have a good night.
Okay, go away. That's right.
Have a good night, Professor.
Good night.
And that'll be the dogs.
Of course.
Sorry.
No problem.
You might hear them. I'll try to keep it at a minimum.
That's quite all right. You have a question? I can't hear you.
I don't have a question, sorry.
So just
Okay.
thanks a lot.
Yes, bye.
Take care. Bye-bye.